Hi, my name is Ernest Yue, and I'm from Berkshire School, class of 2013. And during the past year, I've been working with Dr. Nick Webb from Union College about designing a gesture recognition part for a social robot. So a social robot is a robot that's designed to communicate with people. So in order to fulfill that task, it has to have something to show its response, like a screen, and it also needs something to capture people's reaction, like this one. This one is the Connect is what I use for this project. It takes the image of the user doing gestures and then pass it to the computer. And the computer does some further analysis, and then it will send command to a robot called iRobot Create, which is kind of changed from a Roomba vacuum cleaner. So it will send command to the robot and drive it to run around. So what I use for operating system is this Ubuntu, and I use another software called ROS, which is short for Robot Operating System. It provides a platform that connects all the hardwares like the camera and the robot and the computer, and you can run these drivers as well as the programs on this platform. So here's a chart to explain how it actually works, and they have all these nodes, and this is the platform called ROS Core. So all these nodes are sending and receiving messages on this platform. So what I did is to use the Connect to capture the image and then try to recognize these 5 gestures on this little graph, and each of them corresponds to a move, a command for the robot: forward, backward, stop, rotate, counterclockwise, and clockwise. So we have the controller that actually grabs all the coordinates of the critical points that's gained from the user. So you can see in this little picture, you have hands, head, and shoulders. And after analyzing them, it'll send a reply the commands to the robot. So here's the flowchart of how the controller part actually works. It starts from obtaining new coordinates, and then you run all these tests to test for each of these 4 gestures. And once any of them is detected, it creates a message which defines the angular and linear velocity for the robot, and then it sends the message to the robot. Then it does the stop test, which constantly detects this stop sign. So once it's detected, it'll send a stop message to the robot and stop whatever it is doing. Otherwise, the robot will stop running automatically after 2 seconds. And here are some details about how it actually works: the coordinates, and the double check mechanism, and the stop test. So this research project mainly focused on the static gestures, so it's like actually capturing the coordinates of each point. However, we can also do some research on the moving gestures. Some of them are used in military organizations, and also further program can be developed to detect the finger gestures. So this is basically what I did. Thank you.